All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, you're going to do remove, replace, reduce. So you're going to have x squared plus 7x plus 6. You're going to replace the 3 as you factor. The first one will reduce to x plus 2, and the second one will stay as is. And so that would be your answer. For the math knowledge question, it wants to know what the price would be for 70 member tickets and N non-member tickets. So member tickets are $17, so 70 times 17. And then non-member tickets are $20, so N times 20. So that would be E for this one. We are looking at lesson 35 today, the integral of a constant, the integral of k times f of x, and the integral of x to the n. So hopefully you'll understand a little bit more about integrals when we finish this lesson. In this lesson and in future lessons, we will use the term integration, indefinite integration, anti-differentiation interchangeably. Okay, so all of those are asking you to do the same thing. The integral of k dx is going to be kx plus c. So if you're going to integrate a constant, you're going to just add an x and a plus c. So if it says integrate 4 dx, you're going to say 4x plus c. If it says 5 ds, your variable is s this time, so you would have 5s plus c. So that's how those will work with a constant. If you have k times a function, where k is some number, you're going to pull the k out and then integrate your function f of x. However, you need to be careful to never move a variable across the integral sign. So you cannot do this. It will not work. Don't ever pull a variable across your integral sign. Only a number, a constant. So we want to integrate this. So the way to do that is to pull the 4 out. So you're going to have 4 times the integral of cosine of t dt. So what is the integral of cosine of t? Any ideas? Hopefully you're saying sine of t. Is the derivative of sine cosine? It is. And then we need to put plus c. So you can write it as 4 sine of t plus c. Okay? So that would be your answer. Looking at another example, we have the integral of sine of u du. So again, our variable is u. So what is the integral of sine? Remember, sine and cosine go back and forth. Is the derivative of cosine sine? No. How about, is the derivative of negative cosine positive sine? It is. If you're having trouble still, you need to put your plus c for your answer. If you're having trouble still, you can do this. A negative and a negative make a positive. So we have negative and cosine of u. And is the derivative of cosine negative sine? It is. And so that's another way you can do it if you would like to. Okay, we're going to look at this formula for x to the n. So if you're integrating x to the n, you're going to take your exponent and add 1, and then you're going to divide by the same number that is now in your exponent, and then plus c. Okay, so let's integrate 5s to the negative 20. So we're going to take out the 5 first, so that we can integrate s to the negative 20 ds. So our formula says that we take s to the negative 20 and we add 1 to the exponent. And we divide by negative 20 plus 1. So that's going to be 5s to the negative 19 over negative 19. So I'm going to put the negative out front, and then plus c. And that's your answer. And if you want to check, you can actually take the derivative of this. The derivative of a number is going to go away, so we don't need to worry about the derivative of it. But we would pull the negative 19 to the front, so we'd have negative 19 times negative 5 over 19. And then we would subtract 1 from negative 19 to make that negative 20. And that will cancel. That will become positive 5s to the negative 20, which is what we started with. So that's how you can check your answers on these. Okay, let's look at this one. If you don't want to pull the 1/3 or your constant out front, you don't have to. I'm going to try this one without pulling it out front, just so you can see how it works. So we need to put the exponent here, not as a radical, but as an exponent. So that's going to be t to the 2/3. And then with respect to t, so we're going to take t to the 2/3. We're going to add 1 to that, and then we're going to divide by 2/3 plus 1. So 2/3 plus 1 is 5/3. So we're dividing by 5/3, which is the same thing as multiplying by 3/5, because it's just a reciprocal. And so the 3's cancel, and so I'm left with 1/5 t to the 5/3. And then don't forget your plus c, or you'll lose a point on that problem. Okay, so that's how that one works. For this next one, let's see if you can do it by yourself. If you need me to help you rewrite it a little bit, and then y'all can try it by yourself, you can. What you're going to do is make it, this is a u to the 1/2, so when you move it to the numerator, it's going to be u to the negative 1/2. So from here, you're going to add 1 to the exponent, so negative 1/2 plus 1 is 1/2, so you're going to be dividing by 1/2. Whoops, I shouldn't have the integrals on there anymore. Okay, so if you're dividing by 1/2, that's the same thing as multiplying by 2, so you should have 6u to the 1/2 plus c for your answer. So hopefully some of y'all got that all by yourself. Let's look at one more example. 5z to the pi dz. So see if you can integrate that one by yourself, and then I'll go over the answer. So for this one, you're going to say 5z pi plus 1 over pi plus 1. Can we simplify pi plus 1, really? No, so you just leave it like that, and then plus c. And that would be your answer. Okay, so that's how those work. So hopefully as you practice these, you'll get a little bit better. Eventually you need to be able to get these pretty quickly. So definitely spend some time going back over your homework questions if you need to be able to practice them a little bit more. Alright, so your homework is 1 through 25, so make sure to do those tonight so you can go over any questions you have tomorrow.